All right, another example. So we have a very similar graph. It's still a base of 1/2, but now we've got a little bit more complicated exponent. Don't let this trick you. You need to factor that 2 out. So it actually becomes y equals 1/2 to the power of 2 times x plus 3. All right, now we can actually look what's happening here. So this is my b value of 2, which means that I have a horizontal stretch of 1/2, or by a factor of 1/2. And this is actually going to be a minus 3 here. So that means I'm going a horizontal translation of 3 left. Okay, so now that I know that, I'm going to actually just take each of these points. We do the stretches first. So I'll half them and then move them by 3. So half of 0 is 0, and then we'll move it 3. So 1, 2, 3. And then half of 1 is 1/2, moved by 3 left. So 1, 2, 3. And then again, 2 divided 2 1/2 is 1, move 3, 1, 2, 3. And one more time, half of 3 is, negative 3 is negative 1.5, and then move 3, 1, 2, 3 left. Okay, so that part of the graph is done. Now for our original positive x's, so then we have this again, 1/2, and then move 3 left, so 1, 2, 3. And we're getting the same little pattern. It's going to continue. Now our asymptote has not changed, so don't make it look like this is going to hit the asymptote. So I'm going to stop right there, making it very explicit that that keeps on going there. Which means our domain does not change with these transformations, so it's still negative infinity to infinity. Our range doesn't change because the asymptote's in the same place. So we still have from 0 to positive infinity. And then our asymptote that we were asked for is still at y equals 0. All right, moving on to example 3. So transform the graph of y equals 4 to the power of x to sketch the graph of. So there's some transformations that have happened in here. Describe the effects on the domain, range, equation of the horizontal asymptote, and intercepts. So the first thing I'm going to do is actually look at the transformations. I've got a b value of 2, so that means I have a horizontal stretch by a factor of 1/2. It's reciprocated. We've got a negative in front of that, which tells me we've got some kind of reflection. And because it's by the b value, that's going to be a reflection in the y-axis. Next, dealing with inside this brackets. Now we did have to look, is this 2 been factored out? Does this x have a coefficient of 1? It has. Perfect. So we'll look at this 5 then. So it's going to be minus 5, which means it's a horizontal translation, 5 left. And then finally we have this minus 3. So that's going to be a vertical translation, 3 down. Now once we have that done, I would go and sketch this original graph. So our y equals 4 to the power of x. Now this graph has a really large base, or compared to 2 or 3, it's going to grow really, really fast. So we won't be able to graph too much. So I'll start with 4 to the power of 0. So then 4 to the power of 0 is 1. So that's our height. And then our next one is going to be 4 to the power of 1. Well, that's equal to 4. And then 4 squared gets really big really fast. It's all of a sudden already 16. Now because of that, we won't be able to see much on the negative side either. When we get to negative 1 as our x, we're going to find that it's already 1/4. And I'm not going to graph any more than that because it's going to be really hard to show that that doesn't cross the asymptote. So we kind of have our graph showing that it keeps on going here. We should label that, so that's y equals 4 to the power of x. Now, we could actually go and try to move these 4 points and kind of make them work with this information or these transformations. There's just so much going on, and this graph grows so quickly that I think I'm actually going to use mapping notation here just to make this a little bit simpler. I think it'd be really tough to do all of these in one go. So we're going to look at what happens to the x, what happens to the y. So for things happening to our x, we have a horizontal stretch of 1/2, which means this is going to be a multiply by 1/2. Reflection in y-axis, that's going to make this a negative 1/2. And then we've got our 5 left. So that's going to be minus 5. And then for our y, we just have 3 down. Now we're going to pick a couple points and place them into them. I think some useful ones possibly is going to be this 2, 16. So let's do that one first. So that means that I'm going to substitute in 2 for my x and 16 for my y. So negative 1/2 times 2 is going to be negative 1 minus 5, and then we have 13. Negative 1 minus 5 is negative 6. So we get negative 6 comma 13. Okay, so we can go and plot that. Now that's going to be somewhere over here on our sketch. We will need probably another point, so let's find something else that's going to work out nicely with this 1/2. And I think 0, 1 is a good one. So let's do that one next. So I'll just do it right beside it. So we have negative 1 times 0 minus 5. And that was comma 1, so it's going to be 1 minus 3. So then we get negative 5 comma negative 2. So then we can go and plot that. Negative 5. You can see how much this has already moved. It was at 13 before, and it's already moving to negative 2. So very, very quickly. And the reason is we've actually compressed the graph. So by multiplying by 1/2, it's making this graph grow even faster. So this is going to be negative 5 comma negative 2. Now at this point, it's very, very difficult to do very many more. What's really important is where this asymptote is going to be. This vertical translation is going to push us already down to negative 3 as our height. So we know that's our asymptote from this vertical transformation, so that happens at y equals 3. It might be nice to find one more point, like maybe where it crosses this y-axis would be good. So we're going to do our y-intercept then. So we're going to go y-int, and we're going to let x equal 0. So I'll go substitute that into this equation. So 4 y equals 4 to the power of negative 2, and then 0 plus 5 minus 3. So we end up with 4 to the power of negative 10 minus 3. Now that minus 3 is basically negligible at this point. So in the calculator, it's a super small number. You're going to get significant digits. It's very, very, very close to that asymptote. So it's going to be 0. And this is going to be a little unconventional. I'm actually going to leave it in that form. And just acknowledge that that's incredibly close. So I'm going to have some kind of graph that looks like that. And it's going to keep on going here. We know that for sure. Generally, when we sketch stuff, we are supposed to find the x-intercepts as well. So I will just take a little time and do that here too. So our x-intercept is equal to let's let y equal 0. So we're going to get 0 equals 4 to the power of negative 2, x plus 5, all minus 3. We'll add 3 to both sides. Now we can't solve this at this point. We don't know how to use logarithms. So graphically, you can go make the left side equal to the right side. And you're going to find that x is equal to negative 5.396. So that means if I go and graph this right here, approximately, let's say right here, let's do this in blue to stay a little more consistent to all the other random colors I put there. So negative 5.396 is at a height of 0. So now I can go and actually sketch out the rest of my graph. Know it's as accurate as we can be without kind of grid paper. We haven't actually answered the full question yet though. So we want to describe the effects on the domain, range, and the equation of the horizontal asymptote and x-intercepts. So some of this we've already done actually. So we already have our y-intercept and our x-intercepts, so those are done. The horizontal asymptote we've already labeled as well. So again, I'm going to use a little bit of shorthand. Our horizontal asymptote is at y equals 3. Again, when you're doing this in paper, you should write the whole thing out. Just on the computer, it's a bit tough. And then the last thing is our domain. Well, it's actually still the same thing. X can still be any value, so it's still real numbers, so from negative infinity to infinity. And our range has changed. So while the domain hasn't, the range has. And the range is going to be from our asymptote, so at -3, and then our all the way up to positive infinity. Now I just noticed that this should be a -3 here as well. So just make sure, confirm that that asymptote is at -3. And that means it should be -3 here as well.